Hello, General Biology, and welcome back. We're still in Chapter 1, and this still, believe it or not, is Section 1-1. It's a long section. So I ran over a little bit. I was so excited about talking about collecting and analyzing data that I wasn't watching my time, and I ran over. So this might be a little bit redundant, but to hear it again is not going to hurt. So quantitative data that you're going to collect is going to be something that you are able to measure. So temperature, you're going to be able to count the number of bubbles. You're going to be able to tell the timing or the rate of the reaction. In our example here, it could be the number of plants per the plot that we're looking at, or the plant sizes. And the growth rates, we can look at the time. If we went back every single day and measured, we could count the growth rate as that. Where qualitative data is going to be that descriptive data that's going to involve things that cannot be measured, and those things are going to be characteristics, which we can't measure those. They can't simply be counted. So we can look at this marsh grass and we can say, are there any foreign objects that could have done something? We could look at the color of the grass. Is it brown? Is it green? Is it yellow? We could look at whether it's growing upright or sideways. You know, sometimes sideways, it could be leaning towards the sun. I mean, there's a lot of different things that we could describe, and qualitative is descriptive, and that's what we need to think of. So a scientist, in order to be able to collect data, is going to have certain tools that they're going to be able to use. Tools are going to be a full variety of devices like meter sticks. We could use sophisticated equipment like, oh my gosh, my mind just totally went blank. We could use a microscope, that's easy. We could use a centrifuge. We could use, some of my CSI fans, NCIS fans. Why can't I think of a chromatography machine, which I cannot think of the name of that for some reason. I'm drawing a blank. But we can use equipment like that in order to gather the information. Computers. We could use computers to record the data as well. So these are just some tools that can be used. A calculator. But there are some things that you probably wouldn't even consider as tools. And that would be charts and graphs. You could do a chart. I was at an appointment the other day, and they were doing a genealogy chart to decide, you know, if there was any sort of disease or cancer from both sides of the family. And they asked questions, you know, did your dad or mom or dad have heart disease? Were they diabetic? Did they have hypertension? And they even asked if we knew about our grandparents and on both sides. So that would be a chart, and they would be able to look at that and follow that through. So those are also tools, but we don't think of them so much as tools as we do the computers and the calculators and the meter sticks. So here's one of our tools. We're going to use a graph, and what we're going to do is we took our time and we observed this grass over a couple of weeks, and we recorded the growth in height. And in science, we're going to use the metric system, so we're going to measure that in meters. And we're going to notice that it started off a little bit slow, if we can follow my dot, and then it gradually increased. And when we compare that to the control didn't grow quite as much. Let me see if I can pull, there we go, my arrow. The control didn't move quite as much over that time period. So we can look at this now and compare that the group that received the nitrogen grew much taller than the control. So nitrogen does have an effect on the growth of the grass. When we look at the history of recording, most of everything was done by hand. They were journaled in lab journals. Today we're just going to enter that data into computers, and we're going to make that makes organizing and gathering the data a lot easier. One of the things that we have to watch out for is errors. And errors are going to happen. And when errors happen, they can affect the data that we're collecting. So we need to make sure that whatever data we're collecting it depending on the accuracy of the tool. So for example, if I were to use a regular thermometer to measure the temperature of a liquid, and I'm reading that thermometer and I say that, oh, it's at 22 degrees Celsius, and I'm trying to count the little lines on the thermometer, is that going to be more accurate than a digital thermometer, where if I put a digital thermometer in and it tells me that it is 32 or 22.5 degrees Celsius, which one's going to be more accurate? So our tools that are used to measure the size and the weight of the marsh grass can be limited for their accuracy because of the type of tool we're using. It can be limited because of our skill at using some of those tools. So we have to consider any sources of errors that might exist. Data analysis and sample size must be chosen carefully, and the larger sample size usually gives more reliable results that researchers can analyze. They can look for variation and they can evaluate any differences. If we're just doing a small sample size, that's really not going to give us any accurate representation. And we can compare this between the experimental and the control groups. And both would have to be the same size so that we're eliminating any case of error. From that, we can draw our conclusions. And one of the things that I want you to do when you're drawing the conclusions is, and it's a couple of steps. The first thing is I always want you to rephrase that hypothesis. And people have difficulties with this. Rephrasing means take it out of the if-then statement. We are no longer testing, so we don't need the cause and effect. So we're going to take it out of that if-then statement, and we're going to say the grass in nitrogen, the grass in group B grew because nitrogen was present. We've taken it out of the if-then statement. If nitrogen is present, then the grass will grow. The grass grew when nitrogen was present. So we're taking it out of that if-then statement. The next thing when you're drawing a conclusion that you need to do, and make sure that you're writing these down because when you write your lab report, you're going to need to know how to do this. The next thing is I want you to use background information. And I want you to use this background information to confirm your findings. Or maybe you're not confirming them, but you're refuting them. Maybe your hypothesis was wrong. And refute means to be proven wrong. So here's that refute. Confirm would be support. Refute would be to say, hey, this is totally wrong. Elves do not paint the great blades of grass, period. Okay? So you're going to use that background information to confirm those findings or refute those findings. So what do you know about this? Nitrogen is necessary for plants to grow. It helps to produce the amino acids, which are building blocks to proteins. Okay, so that's your background information that you know. The third thing that you're going to need to do is use concrete examples. From your observations as support. in this statement. Okay, so, oh boy. So we're going to use these concrete examples from our observations. So we're going to give measurements. We're going to use quantitative examples when we can. And we're going to use qualitative examples when we can for this. So we're going to be using those concrete examples to back up what we said. If there was any error, this is where we're going to put the error in. You know, you might not have error, and you don't have to say I don't have error, but if there's any error, this is where you want to account for it. Maybe you didn't know how to use the measuring device or the thermometer correctly, or maybe you had difficulties controlling the temperature, or you looked away when you were counting the number of bubbles, or something. And this is where you would account for that so that we can look at that and say, oh, well, maybe that had an effect on it. And then the last thing is you want to tie everything together. This is where you want to analyze and summarize what you said up there. So I want to come back and say that nitrogen is essential for grass growth in the marshlands. Without it, the grass is unable to grow. I'm just going to pull everything together. It's called a summation, but it's going to pull everything together and say, hey, this is what it is. So when you're making conclusions, I want to see those 5 parts in the conclusions in order to make it a valid conclusion. So our analysis showed that the marsh grass grew taller, then controls by adding the nitrogen. So that's what our analysis is, and then we can draw that conclusion that you would have. Okay, so new data. Sometimes you might find new data that says, hey, my hypothesis wasn't right, but it added a new question. So hypotheses can be revised. And we can revise them and redo experiments several times before we come up with a final conclusion on this. All right. There are scientists that don't practice science in the lab. They go out in the field, and they are called naturalists. My favorite naturalist is Jane Goodall, who deals with the chimps in Africa. These are scientists that they go out in the field. They study animal behavior. They collect data in rainforests. They collect data in oceans. And here they might not actually be able to control single variables, or they might have to just observe and control what variables they can. Jane Goodall sat on the same peak, wore the same color clothes, was there from the same time in the morning to the same time at night, and then she just watched and observed. That was what she was able to control for her experiment. And we're going to take a look at a video on here. We also have to worry about some things like ethics. Ethics prevents certain types of experiments, especially when human subjects are concerned. So we need to be careful with that. And you might hear of blind studies and double-blind studies that are done with humans. But they sign waivers because you really can't test on a human unless they're willing. So that's a possibility. Researchers will still try to control as many variables as possible when they're doing experiments or they're studying things out in nature. And researchers will always try, if they can, to study large groups of subjects so that individual genetic differences don't produce any misleading results. So if you can, click on that video and watch the video. If not, we might see that in class. Okay, so that's the end. There's 3 screencasts for section 1.1, and hope you enjoyed them. Bye.